welcome to Chapter 5, Preparing for Proofs. Dun, dun, dun. Okay, so we are going to be primarily talking about reasoning and logic. Okay, logic is essential to the study of geometry, and it's actually essential to the study of a lot of things, but math is, what you usually really concentrate on logic. So it was required during school way before even Jesus was around. Okay, logic, rhetoric, which is debating, grammar, okay, those are all foundational stones for logic and reasoning. Okay, so your grammar teacher throughout the years, you learn to reason without ever even knowing logic. Okay, so where to put a comma, where to put, when to use which tense of which verb. So you've actually already done some reasoning in the past, okay, but we're going to be talking about a specific kind of logic called deductive logic, and that's how you write a proof. There's lots of different kinds of proofs, but that's the ones we use in geometry. It's called deductive proofs, okay, and that's the main topic of the whole chapter. But we're going to ease into it a section at a time, so buckle your seatbelts. It's going to be fun. Okay, so if you look at your textbook on page 160, this was the beginning of 5.1. You see a picture of Sherlock Holmes. It's not the ones we watch right now. I don't even know if he's from a specific series or whatever, but this is Bob Jones, Sherlock Holmes, and you know that he's a famous detective in stories, and he is the king of deductive reasoning. He always can figure things out, and that's basically what we are. If you think of learning the rules to a game, like say you want to start a sport, you're going to play football. Okay, so if you were never played football before, you first would have to know the rules. You have to know techniques. You would watch other people play football. Then you would start practicing the skills. Okay, so if you're a beginner player, you're not expected to be this highly competent player, but you're going to make rapid improvement as you practice. Okay, just like with any skills, the better you get, the more you're going to like it. Okay, so if you don't practice, you're not going to get better at it, and that's the whole idea with proofs. Okay, it is like a game. So reasoning, your first definition, is the step-by-step process that begins with a well-known fact or assumption and builds to a conclusion in that orderly, concise way. Okay, it's called logical thinking. So when we go to make logical deductions, we have to make sure that we have the information to not jump to conclusions. You've heard that expression, oh, you're just jumping to a conclusion, you don't have all the facts. Well, that's what we are practicing, making sure we have all the facts. This cartoon is in your book on page 161, but I thought it was really clever, I guess. If you take a minute and read it. Okay, so basically the dad has all of these reasons that he's come up with that his son probably shouldn't drive. Okay, it had nothing to do with going on a date. But what did the son conclude? Okay, the son's conclusion wasn't logical. It didn't follow any steps. In fact, the only thing the father concluded was he thinks he needs a little more experience driving, right? And saying he doesn't like Sally. Those two things don't go together. All right? So we're going to practice. This example is not in your book, so I want you don't have to write the whole thing down, word for word, but you're going to make sure you have the numbers that are represented. It's important. And you're going to probably have to rewind. Okay, Okay, so once, because we're going to do 3 questions are going to be asked of us based on this word problem. So Memorial Hospital employs 37 doctors, 59 women, and of the 15 employees under 25 years of age, 9 are not doctors. Dr. Novak is the only woman doctor under the age of 25, and though 10 other doctors are women, how many doctors are over 25? So the first thing we have to do is come up with our sets. So we're going to identify the 3 main sets. Before I tell you what they are, go back and read the problem again and see if you can identify 3 main sets. Okay, they are doctors, women, and then employees under 25 years old. Okay, obviously there's some overlap, right? We know that there's some women that are doctors. We know there's at least one woman that's under 25, but those are the 3 main sets. So the second step is to draw a Venn diagram, okay? And we're going to try to fill it in as much as possible. So if we have 3 sets, we have 3 circles, and they overlap, okay? And so I've got our doctors, women's, and employees under 25. Okay, the Y is employees under 25. Okay, so now we have to figure out where they overlap. So if we said, it said that, let me make sure I'm reading my own question right here, 9 are not doctors. So if I take 6 and say that 6 are under 25 and 6 are doctors, that means I have to subtract 6 from both of them because I have to have the total number. It says that there are 15 employees under 25, but if 6 of them are doctors, right, doesn't that leave 9 that are not doctors? Okay, so I just want you to see what's happening here. So now I'm going to do the same thing with women. One of those women was under 25 and a doctor, so they fit all 3 sets. Okay, and I have 10 other doctors are women, right? So I had to subtract the 10 off from women and the 10 off from the doctors. And then the last question, well, first let's look at the little empty space. There isn't one that is not a doctor and a woman. Did you notice that? There's an empty space between the 25 and under and the women. That's because that one person was also a doctor. So there isn't anything in that set there. It's an empty set. So how many doctors are over the age of 25? So can we look at that and see how many are over 25? Okay, the answer would be 31. I know that you're going to want to say 21, but you have to remember the 10 women that are also doctors. This example is in your book, and your WISC summary is going to be something that you want to set up much in the same way as the example. It's on page 162. Okay, so if you want to read along the logic steps that they give you, but basically you got to read the question first. It's kind of long. Bob, Jim, Phil, and Brent are part of a crew of commercial tugboat. Their jobs, not in any particular order, are captain, first mate, cook, and mechanic. The mechanic is the first mate's younger brother. The captain has no relatives on the crew, but Brent does. The first mate is not the cook's uncle, and the cook is not the mechanic's uncle, but Bob is Phil's uncle. What job does each man have, and how are the men related to each other? Okay, lots of information, and it's a little bit circular in how you read it. So we're going to make a chart for this one. Okay, so here would be how you'd want to set up your chart. I have Bob, Jim, Phil, and Brent down the side because I know their names. I also know that Bob is Phil's uncle and Phil is Bob's nephew. Okay, and then I have the 4 positions on the crew. which is captain, first mate, cook, and mechanic. Okay, the first mate is the brother to the mechanic and not the cook's uncle, and the mechanic is the brother to the first mate and not the cook's uncle. Or, I'm sorry, not the cook's nephew. So I just kind of put little information that I know under the position and under the names. So I can start off with just kind of rereading. It says, the mechanic is the first mate's younger brother. That's where I got that. The captain has no relatives on the crew, but Brent does. That sentence right there, I'm going to start with, if the captain has no relatives and Brent has a relative, that means Brent is not the captain. It also means Phil and Bob are not the captain because they have relatives on the ship. That only leaves Jim as the captain. Now, if Jim is the captain, then he cannot be the first mate, the cook, or the mechanic, because each person just has one job. Okay, so you can just X out the rest of those. Now, some you might have to guess sometimes and see if it works out, but right now we've got some more information that we can go with. Okay, we know that Bob is Phil's uncle, so he can't be Phil's brother, which would eliminate him from being the mechanic or the first mate. Okay, so since the cook isn't supposed to be the uncle, Bob would have to be, or couldn't be the cook either, so there's actually no job left for Bob. So our guess is that Phil is one of the brothers, must be wrong, right? Okay, so we can cross out Phil from the jobs of the mechanic and the first mate. Okay, that just leaves Bob for the mechanic. So since he's a brother, he's not the cook's uncle, right? So that means if he's not the cook's uncle, then that means what? Phil can't be the cook. Oh, right. If Bob is the mechanic, then nobody else is the mechanic. So we can X all of those out. And I just said that means he's the brother to the mechanic, not the cook's uncle. So that means that's the only places left is that he's the cook's uncle, which means he's Phil. You know, we know he's Phil's uncle. So there we go. Now that just leaves Brent, and we already know he can't be the cook because Phil is, and that means he has to be the first mate. Now let's see if it works out. Brent has a relative, which means if he's the brother to somebody, right, then that works out. So there we go. Okay, so your whisk summary is to answer these two questions. Okay, who likes pecans and what does Lance like? So we got Lance, Terry, and Jen, and Kelly. They prefer each different type of nut. Lance detests almonds. Kelly likes cashews. Jen cares neither for almonds or walnuts. Okay, so I'm going to help you with setting up of the chart. I want it to look like this. I just thought this would save you a step of trying to figure out. You've got your people down the side, and you've got what they like or dislike along the top. So your goal is to find out who likes pecans and which one does Lance like. So you can actually find out what all four of them like. Okay, and it says they each prefer a different kind, so you won't have any overlap. Alright, so go ahead and submit that through email, and I'll see you in class.